Hi everybody, this is the second video to 2.9. I'd like to start you on page 37 on differentials. And what I would mostly like you to notice is the notation dy dx just means the ratio of two quantities. Dy and dx themselves are called differentials. Okay, now what I would like you to recognize here, we're used to these two symbols to mean the derivative, right? And again, what it means is as x changes, that's dx, we can find the amount that y changes, okay, dy. Now, what I would like you to also recognize is when we have dy dx is the derivative of the function, we can also multiply both sides by dx. Yes. So it will cancel here. And now we have dy equals f prime of x dx. Okay, and that's what we're going to fill in to this box here. That's our differential. All right, let's take a look at example 5 and actually compute this. All right, now let's take a look at example 5, and they gave us a function. We need to take the derivative of that function. So we need to do both the product rule and the chain rule. Let's go ahead and review this one really fast, even though we just had our test on it. But it's a little tricky. So let's first take the derivative of 2x, and we're going to multiply them by the second part of the function. And then we are going to take x squared and multiply by the derivative of the second function. Now careful, the second function is the chain rule. We have an outer function here, the sine of x. We have an inner function here, the 2x. So let us take the derivative of sine, which is cosine, leave the inside alone, but then we have to take the derivative of the inside function. So if we simplify that, we'll get this, and please notice I just cut up here, I put a times there. That should have been a plus, right? I fixed it here, and let me fix it up here for you. Okay, now let's continue. We know our differential is dy equals f prime of x dx. That's what we just did about 40 seconds ago. So if we want to know what our differential is, we take our derivative here, right? And we multiply the whole thing by dx. Do you see that? dy f prime dx. If we take a look at the next example, let's apply this. Everybody, I'm going to pause the video, and I'm just going to take the derivative of y. I'm going to do the quotient rule, okay? I have my quotient rule. I'm just going to distribute that negative and combine like terms next. And we're going to cancel here. All right, so we found the derivative using the quotient rule. Now let's go ahead and find the differential. This is the new part. Let's do this in red. I'm going to multiply both sides by dx. All right, so now I have my differential. And let's keep doing this. They want us to evaluate dy, that's this guy, and we need to evaluate that when x is 2 and dx is 0.05. So all we do here, guys, is simply substitute these values. Okay, I'll do that in green here since it's very new. The blue is kind of old stuff. we have negative 2 dx over x minus 1. Now x is 2, correct? They told us that right there. But now they also told us what dx is, right? So instead of writing my dx here, which is very new to us, we're just going to write, excuse me, instead of dx, we are just going to write 0.05, what they told us dx equals, yes? All right, so there we have it, okay? They ask us to interpret this answer. We're sort of new to this, so let's definitely interpret this answer. So what this means, for our tangent line of this function at x equals 2, the tangent line is going to decrease by 1/10 as x increases from 2 to 2.05. Now where did I get the 2.05 from? We started with 2, we changed to x by 0.05, so that's 2 to 2 plus 0.05, which is 2.05. And although at the moment I'm not going to test you on problems like these, I'm going to do them anyway because you're going to be presented with them in future courses. Okay, so we have a circular disc and a maximum error. All right, so we need to take the derivative. And again, this is new. We're going to need to take the derivative. We're good at that. But we're talking about the radius here, the maximum error in a measurement of the radius. So in this case, when we do our implicit differentiation, we have to take the derivative with respect to r. All right, so let's do this. Derivative of a is 1, okay? But we have to tell everybody, hey, we just took the derivative of area, but with respect to r now. Now let's take the derivative of pi r squared. It's with respect to r, so we're all good. Now, let us multiply both sides by dr. Okay, and they gave us the radius here, so we can go ahead and plug that in. And they gave us the error, the difference that's allowed, right? The maximum amount of error. That's considered our dr here. So we've just calculated the maximum error in the area, okay? For letter B, what is the relative error? What is the percentage error? First, let's go ahead and figure out with our desired radius, what would the desired area be? Okay, relative error, let me show you what that is. Perhaps you might be seeing this formula in other classes here. Our relative error, maximum error over the actual value. So we have our maximum error right here. We have the actual value right here. And that'll come out to be about, so the percentage error, of course we just move our decimal place 2 places to the right, right? Multiply it by 100. Whew. So you'll be doing that in future courses more. But for right now, that's just an introduction for you. I hope it was helpful.